So good afternoon students. So in the last class we have discussed about what are the different methods of preparation and purification method of colloids. In that I told you different types of methods like ultrafiltration. So by using dialysis technique. So different types of techniques there to purify the colloids. As it is having very less particle size range, so we need a specialized filter method to purify it. With this, today I will discuss about some important part of these colloids, properties of the colloids. So there is a specific properties of the colloids we can see that generally will affect its preparation method and to stabilize it. So generally the particle size is the first property of these colloids because we have to keep it in a range, that is 1 nanometer to 1 micrometer the particle size. So that's why different types of methods we are using to determine the particle size of the colloids. With this also with this particle size some of the important other properties also there, like your optical properties. There is some optical properties of the colloids also there. So to know these optical properties we need to go for different types of techniques like light scattering method. So what is this light scattering? That means when we are inserting one light ray towards a sample or towards the colloid preparation, some of the light ray will be will cross the sample. If particles within the ray, then what will happen? That light ray will be in contact with the particles and it will make it charge, make it dipoles. So the dipole particles will emit weaker length of light source having a same wavelength. That means when we are inserting the light, it will bombard with the particle. It will be in contact with the particle and the particle will be chargeable and it will be polarized. The particle will be polarized, and when it will polarize, when it will produce the dipole, it will also emit some amount of light which is generally weaker than the incident light, but it is having a similar wavelength. So that type of phenomena we are telling as light scattering. With this, some of the other effects also we will see, optical effects we will see, like your Tyndall effect. Tyndall effect means when we will try to incident a light ray, what will happen? It may cross the liquid. It may cross the liquid, and when it will cross, we will see the particles in the beam. In the beam of light, we will see the colloidal particles. For example, when in the dark room will glow on torch, then in that light, in that glow of light, we'll see some particles are moving in a movement, in a Brownian movement, in a random motion. The particles are moving in a dark room. When we will glow the torch, switch on the torch, in the light ray, we'll see some of the particles. So that type of effect is known as your Tyndall effect. And that beam you are calling as, that scattering beam, we are calling as Tyndall beam. So this type of Tyndall beam or Tyndall effect also we will see in case of colloids also. So now let us come to how to evaluate this property. So first thing, by using a light microscope, we can also find out the particles present in the colloids. So generally in the light microscope, what we are doing, we are using a visible source of light. We are using a visible source of light, and if the particle size is within the range of 0.2 micrometer, then only it can be visible. If it is less than that, it is not visible. If it is 0.2 micrometer, then it will be visible. If it is more than 0.2 micrometer, then also it can be visible. And these particles will show us like a blur. A blur image we will see in the light microscope. But in the colloids we know that the particle size may be very less. So that's why always this light microscope is not effective. Is that much effective for that colloids. But still, if particle size is slightly more, then we can easily identify the particle sizes. Then coming to another technique by using ultra microscope. So here we are see you are taking Tyndall beam or Tyndall effect, what I told you. Tyndall beam we are taking in the case of like ultra microscope. So I have drawn here the principle here how it is able to detect the scattering beam by using a ultra microscope. So for that, first thing we are taking a source of light. We are taking a source of light in the ultra microscope. Then we are using a cardioid condenser. We are using a cardioid condenser, and through this cardioid condenser we are inciding the light through the sample. That means the colloidal dispersion will be placed in a test tube, and through this cardioid condenser we are inciding the ray. We are inciding the ray towards the sample, and the sample, the ray we are inciding should be cross the sample, and some of the light will be diverged and some of the light will be act as scattered beam, and that scattered beam can be seen under this ultra microscope that is placed here. Ultra microscope is placed in the bottom, and that scattered beam we can see under this, and then this slit also present which will incident the emitting rays, and through which we can see how it is how the particles are inciding scattering through this wavelength, which type of wavelength light is scattering through this sample. So this is one principle given for the ultra microscope. Then coming to electron microscope. As you know that electron microscope is very sophisticated. We are using to find out electrons also in the electron microscope. It's very sensitive, and for that we are using a radiation source as a beam of high energy electrons. We are taking a beam of high energy electrons, and the wavelength we are taking the range of 0.1 Armstrong, and which is very less. That much less wavelength we are taking will take the resonance power will be more. The clarity of particle sizes will get more. So that's why that much less wavelength will take here in the electron microscope. That much clarity will get, that much resonance will get from that. So that's why also this electron microscope will give a photo of the electrons of the particles, small particles present inside the colloids. Then coming to another phenomenon, another property, turbidity. So turbidity also will get from these colloids. So what is this turbidity? When we are inciding one light, some of the light will be observed through the particles, and some of the particles will, some of the lights will transmit it. Some of the light will be observed, some of the light will be transmitted. So here, to know that we are using spectrophotometer. We are using a spectrophotometer to analyze how much amount of light is observed, how much amount of light is transmitted. So that's why we are taking a formula here to find out the turbidity. I divided by 0 is equal to exponential of minus tau L. Minus tau L we are taking. So here I0 means intensity of incident light, I means intensity of transmitted light, L means length of the sample or path length we are telling, tau means turbidity. So it is a simple method of the spectrophotometer. This equation also we are using in the analysis to find out the absorption, how much amount of light is observed or observance. To find out that also we are using spectrophotometers. And with this also we are using some other methods also in the optical properties, like your nephelometer. We are using nephelometer. Nephelometer also we are taking to find out the this particle sizes, what is the range, and how the optical properties will shows. So for that nephelometer, the amount of dispersed particles should be low, then only we can use this nephelometers. So generally in this nephelometer we will find out intensity of scattered lights. Intensity of scattered lights we can find out by using this nephelometer in a particular angle, that is right angle to the direction of light, incident light. We will find the intensity. So then you coming to another technique, light scattering. By using the light scattering method also we can find out optical properties. So generally if you use, because colloids we can prepare different types of colloids there. Some of the colloids are in complex in nature. Some are more viscous, some are some proteins also present. Sometimes we are taking polymers, sometimes association colloids there. So in that cases, normal spectrophotometer or nephelometer cannot detect the sample. So for that we need to use some specialized technique like light scattering technique. So for the polymers, for the proteins, for the association colloids, for lyophobic colloids, we need to use this type of light scattering method. So in this, if the particle size is spherical, then scattering will be same in all directions. If it is spherical shaped particle, then scattering will be in all directions. But if it is rod shaped, then it will be different type. It will be different orientation towards flow of the liquid. It will give different types of effects. So for that we are using a different types of principle. The formula I am writing in the light scattering we are using. There also we are finding the turbidity 16 pi divided by 3 R90, where R90 is equal to IR square divided by I0. So see, in the light scattering method we are using this formula to find out the turbidity. In all cases we need to find out turbidity. So to find out this turbidity we need to use this equation, 16 pi divided by 3 into R90. R90 means it is a ray-like ratio. It is a ratio, ray-like ratio, and that ray ratio we can find out by using this equation, I R square divided by I. I means, already I told you what is I, what is I0. I means intensity of scattered light. I0 means intensity of I means intensity of the incident light. Then we can find out R by distance of the scattered particles. Tau means turbidity. So these are the things we can find out the turbidity by using the formula. But before that we have to find this ray light ratio, which is the ratio of intensity of the incidence light divided by incidence of scattered light into distance between the scattered lights, scattered particles to the point, from the point of observation. Like it is like a path length. So by using this formula we can find out the light, we can find out the turbidity. So these are the techniques by which we can find out different properties of colloids. With this there is another property also, kinetic property, which is also important. So the kinetic property we will discuss in the next class. Thank you.